Hello everyone. In this video we're going to be talking about the make one miss one activity. So for the first part, the question is, in basketball, what is your 3-point conversion percentage? So to simulate that, we're going to use this website. Ooh, 7 out of 8. Okay, so now that we've established that I'm actually pretty good at that basketball game, let's go ahead and figure out my conversion rate. So I'm going to get how many shots I actually made, which was 7, and I'm going to divide that by the total amount of shots that I actually took, which was 8. So 7 divided by 8, what is 7 divided by 8? Let me go to the whiteboard. So after some work, as you can see right there, 7 divided by 8 is 0.875. And if we convert that to a percentage, we can see that my conversion rate is actually 87.5%, which is pretty close to 90, so not too bad. So for the second part of the problem, we're going to look at Maya's 3-point percentage, which is currently less than 50%. But she develops a new technique that allows her to make one shot and then miss the next one. So for every shot she makes, she misses the one after it. So with this technique, what do you think is going to happen to her percentage? Is it going to go up? Is it going to stay the same? Is it going to go down? Or does it depend? So try to predict the outcome and make sure to also explain why. So let's look at a couple of different ways to solve the problem. One way is actually to use tape diagrams. And remember that a tape diagram is just another way to represent a ratio. So let's say Maya takes 10 shots and she makes 4 of them. Then the 3-point percentage is 40%. So now what happens if Maya takes 1 shot? Well, we could just add 1 green square, and we'll see that the ratio between the green squares and the red squares is 5 to 6. And the percentage is actually 45% now, and that's an increase from the 40%. And the same thing happens if Maya takes 3 shots. So the 3-point percentage now is 46, because the ratio is 6 to 7. And again, we do the same thing. Combine the green squares with the green squares, and the red squares with the red squares. And the same thing happens if Maya takes 5 shots, or 7 shots, or 9 shots. And any odd number of shots, if you try them out, you'll see that the percentage always increases from the original 40%. And now let's look at even numbers, like let's say 2. Again, we start with 40%. And we see that if Maya takes 2 shots, she'll make the first one and then miss the second one. Then the ratio goes from 4 to 6 to 5 to 7. And the percentage goes from 40% to 42%. And again, if Maya takes 4 shots, then the percentage goes up to 43%. And if Maya takes 6 shots or 8 shots, or really any even number of shots, the result will be the same. There will be an increase in the 3-point percentage. Another approach is averages. So let's say Maya takes 100 shots before switching techniques, and then 100 shots after. Then from this diagram, we could see that, again, I just chose 40%, just because it's less than 50, and then after the switch, it goes, the 3-point percentage goes to 50%. And if we average them out, because the number of shots was the same, we'll get 45%. And we'll get the same result if we just combine the red with the red and the green with the green. So again, from that 40%, it'll go to 45%, which represents an increase. So I want to emphasize that these are only 2 approaches. Obviously there are more, so feel free to share them. Even if you didn't get that the percentage goes up, there's no shame in getting a different answer. This is just about discussing and talking about it and explaining why. So yeah, thank you for watching.